I will be discussing the problem clone graph. The problem statement says given a reference of a node in a connected undirected graph, return a deep copy clone of the graph. Each node in the graph contains a value int and a list of node of its neighbors. Test case format. For simplicity, each node's value is the same as the nodes indexed, one indexed. For example, the first node with value is equal to 1, the second node with value is equal to 2, and so on. The graph is represented in the test case using an adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node with value is equal to 1. You must return the copy of the given node as a reference to the cloned graph. So a deep copy means we can create new nodes, not reusing the original ones. Each original nodes map to exactly one clone node. All connections, neighbors must be recreated correctly. Graphs can contain cycles. A connects to B, B connects back to it. Self loops, A connects to itself. Third is multiple shared neighbors. DFS, so we will be using the approach DFS using recursion. And adjacency list, as I they describe the definition of adjacency list. Given any node, we should be able to go through our entire graph. Intuition is we will take nodes, make copies, and for its neighbors, basically just create copies of the connecting connecting all the nodes together. The DFS stop once we have already cloned a node that we want as a neighbor. If a node doesn't exist, then we go ahead and clone it. And if it does, then we take that node and append that to our current neighbor's neighboring list. How do we keep track of our clone nodes and original nodes? What we want essentially is a pointer between our original node and our cloned node. We can do that through a dictionary, and the time complexity of this solution is big of n, and space complexity is also big of n. The patterns which is observed while solving this problem are first is graph traversal, BFS DFS. Second is graph cloning, graph copy pattern. Third is hash map for node to node mapping. Fourth is avoiding revisited nodes in graphs. Fifth is graph cycle handling. Sixth is adjacency list graph representation. Seventh is deep node pattern for reference structures. Eighth is recursive DFS pattern. Ninth is iterative BFS pattern. 10th is connected components through though which is unused in this problem, but it has the same idea.